Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 8.2, exponent quotient rules. So for our warm-up, you are supposed to simplify each, and this combines stuff from the first quarter about adding, subtracting like terms, along with the stuff from last time about multiplying two terms together. Okay, so number 1 and number 2 should definitely have different answers. The first one is 3x plus 4x. So remember when we have like terms, they have the same variable and the same exponent on those variables, you can add the coefficients in the front. So 3 plus 4 becomes 7, and then we keep the x there. Please do not start increasing the exponent on the x here. All right, so number 2, this is a little bit different. This is what we did last time. So 3 times 4 makes 12. Okay, we multiply the coefficients in the front, and then we can add the exponents here. So this will become x to the 1 plus 1, which is x squared. And that's because x times x is x squared. Okay. All right, number 3, we have an adding and subtracting. So we do 3x squared. This is like terms with negative 5x squared. So 3 minus 5 is negative 2x squared. And then the plus 4x doesn't have any like terms, so we just bring it down and write it in the end. Remember, even though they both had an x, x squared and x to the first power are not the same, so they're not like terms. Number 4, this time we are multiplying all of it together, so we'll multiply the coefficients in front. 12 times negative 5 is negative 60. And then we can add the exponents for our shortcut rule. 2 plus 1 is 3, and 3 plus 2 makes 5. Remember, if I was to expand this out, I could put all my coefficients in the front, 3 times 4 times negative 5. Then there's the x squared, here's the x, and here's one more x squared. So you can see that there are 5 x's. But we could just do our shortcut rule, add the exponents. Okay. Number 5, I have 5c d squared, all of that to the third power. So this is our power rule here first. So we're going to put little exponents on the 5 and the c. So that's 3 times 1 for 5 to the third power. That's 125. 3 times 1 for c to the third power. And 3 times 2 for d to the sixth power. All right. Number 6 combines the product and the power rule together. So first we need to do the power rule on this part and on this part. And then we'll do the product rule, multiply them together afterwards. So 2 squared becomes 4, and 2 times 1 will give us x to the second power. And then over here, negative 3 to the third power is still a negative, and then 3 times 3 will give me x to the ninth power. Okay, so then I have a negative 1 coefficient in the back and a 4 coefficient in the front. Negative 1 times 4 is negative 4. And then I can combine the exponents with adding, so it becomes x to the 11th power. Okay. Number 7, same thing. We have the power and the product rule in here. So first we must do the outside exponent. So this will become 4m to the second power, 2 times 1 for 2, and then n to the fourth power, 2 times 2 for 4. So if I covered up all the m's and n's, you can see that says 2 squared. That's where the 4 came from. And then we're going to multiply that by 3m cubed n squared. Okay. So now we do our coefficients. 4 times 3 makes 12. We have some n's and some m's. So there's 2 plus 3 for 5 exponent on the m, and 4 plus 2 for a 6 exponent on the n. Okay. And number 8, if we cover up the x's and y's, you can see that's negative 7 in parentheses to the second power. That's negative 7 times negative 7 for positive 49. Okay, that's a 1 exponent times by 2. But be careful, the parentheses, keep that negative there for the base. All right, so then we do x first power with a 2 on the outside. So 2 times 1 makes 2. And 2 times 2 here for the exponent on the y will make 4. So 49x squared y to the fourth. On the bottom here we have our first rule, quotient of powers property. So let a be a non-zero real number and let m and n be positive integers such that m is greater than n. Then we could do this. Words to divide powers having the same base, we just subtract the exponents. And we'll see why in a second. But for instance, if we had an algebra, so a is our base, we have an m for the exponent on top and an n on the exponent for the bottom, then we can do a to the m minus n, which is as long as a is not 0, so the base can't be 0. And here's an example. This is 4 to the 7th over 4 squared, which is 4 to the 7 minus 2, or 4 to the 5th power. And here's why. So if we expand it 4 to the 7th, we would have 1, 2, 3, 4, 5, 7 4s on top. And if we expand it 4 squared, we would have 2 4s on the bottom. And you could see 2 of these would cancel with 2 of those. And that leaves 5 extra up top, so that's why it's 4 to the 5th power. All right, so use the quotient of powers rule to simplify and write your answer using exponents, so we don't have to actually work out like 4 to the 5th power. All right, so number 1, 9 to the 12th power over 9 to the 5th power. So that's 9 12s all multiplied together on top and 5 on the bottom. So the 5 on the bottom would cancel 5 of the top ones to leave us with 9 to the 7th power, 7 9s up top. That's just 12 minus 5, and there are more 9s up top, so we keep the exponent there. All right. Number 2, negative 2 to the 4th power over negative 2 cubed. This is just going to be negative 2 to the 4 minus 3, which is first power, but we don't write first power, so we'll just go ahead and write negative 2. All right. Number 3, 6 to the 3rd power times 6 to the 4th power over 6 squared. So before we could do that division, we got to work left to right, so we got to fix our top first. So this will become 6 to the 7th power over 6 squared. And then 7 minus 2 will make 6 to the 5th power. Okay, we got to make it into one base up top before we can put them together. All right, number 4, 1 over r to the 5th times r to the 8th over 1. So first let's multiply the fractions together. We'll multiply the tops to get r to the 8th. And then r to the 5th times 1 is the bottoms multiplied together for r to the 5th. So that's r to the 8 minus 5, which is 3. So r to the 3rd power. Okay, on our last page, we have our last rule here, power of a quotient property. So let a and b be the real numbers, with b not being 0, and let m be the positive integer. So in words, we want to find the power of a quotient. We just find the power of the numerator and the power of the denominator, and then we would do the quotient normally. Okay, so in algebra here, we have a and b. They could be the same base. They could be different numbers here. And then we have raised to the power of m. So we have a to the m, b to the m, where b is not equal to 0. So here's an example. Here we have 5 as our base in the first one with an exponent of 1. And on the numerator, our denominator, we have 2 as the base with an exponent of 2. So we would just take the exponent on the outside, power on the outside, and multiply it to the powers on the inside. So 3 times 1 will give me 5 to the 3rd power, and 3 times 2 will give me 2 to the 6th power. And then we would divide this normally. Okay. All right, number 5 says simplify each. So remember, our exponents in here are 1 and 1. So 6 times 1 gives me c to the 6th power, and 6 times 1 on the bottom will give me d to the 6th power. All right, number 6, negative 2 to the 4th power. So we can go ahead and work that out. That's just negative 2 times negative 2 times negative 2 4 times for 16. And then on the bottom, we could do 4 times 1, which is y to the 4th power. Okay. So on top, we could have shown another step in between if we felt like it. It would look like this. This is negative 2 to the 4th power, so I'll go ahead and times the 4 to the 1 exponent that's with the negative 2. And then we would end up with 16 over y to the 4th. But you can do that in one step. All right, number 7. First, we'll do our power on the outside. So this will become 3 times 2 for x to the 6th in the numerator, and 2 times 2, so x to the 4th in the denominator. And then we use the rule we learned on the last page, which we can then subtract the exponents to make this x squared. Okay. And number 8, same kind of thing. 3 to the 3rd power is just 27. Go ahead and write in 27 there. And then 4 times 3 will give me a to the 12th power. And on the bottom, 5 to the 3rd power is 125. And the b had an exponent of 1, so 3 times 1 will give me b to the 3rd power. Okay. All right, this is our last problem, number 9. We're going to do 2 things. We're going to do our power rule to a quotient on the first term, first part of the term, and then we're going to times that together with this afterwards. So let's see. So 3 times 7 will give me x to the 21st power on top. And then we had a 1 exponent for the y, so 7 times 1 will give me y to the 7th power on the bottom. And then in the next fraction, we have 1 over 3x to the 8th. So we'll go ahead and we'll times our fractions together. So that's x to the 21st, and then 3x to the 8th, y to the 7th. Now, if we just had x to the 21st over to x to the 8th, you could see easily that the x's cancel. They still cancel just because we have a 3 and y in there doesn't change it. So it's 21 minus 8 would make x to the, let's see, that's 13 power. And then all the x's are gone from the bottom of my, or the denominator of my fraction, so I just get 3y to the 7th left over. Now I can't put the x's and y together because they have a different base. So this is our final answer here. All right, so you have a follow-up here. It's complete the Khan Academy module using exponent rules to evaluate expressions, and is due no later than the day after next. It does not include the division ones, so it's just a review of the stuff we did last class. So you should be able to complete it hopefully, but if not, it'll let you know you need some more practice with the last lesson. All right, I'll see you in class next time.